We now discuss the solution of a problem from the section Integral Calculus, and the problem is on the definite integral as the limit of a sum. This question has appeared in the joint entrance examination main held on 24th June 2022 in the second shift. The given problem is limit n tends to infinity in brackets n square by n square plus 1 into n plus 1 plus n square by n square plus 4 into n plus 2 plus n square by n square plus 9 into n plus 3 plus etc. plus n square by n square plus n square into n plus n is equal to. We are given four options. Option A, pi by 8 plus 1 by 4 log 2 to the base e. Option B, pi by 4 plus 1 by 8 log 2 to the base e. Option C, pi by 4 minus 1 by 8 log 2 to the base e. Option D, pi by 8 plus log of root 2 to the base e. So we are given this expression, and limit n tends to infinity of this is equal to one of the following options. We'll now discuss the solution of the problem in detail. So limit n tends to infinity of that big expression what we have, and we will now write down as in the sigma notation, summation notation, that is limit n tends to infinity sigma r is equal to 1 to n of each each term. In each term n square n square n square is there, so n square by n square in the denominator n square plus 1 n square plus 4, that is n square plus 2 square, and this is n square plus 9 means n square plus 3 square, and in the nth term n square plus n square is there. Therefore it is the general term is n square plus r square, and n plus 1 n plus 2 n plus 3 n plus n will suggest you n plus r, where r runs from 1 to n. So this is your uh, the given expression is written in the sigma notation like this. In the denominator, from n square plus r square take n square common, and from n plus r you take n common. So that will be equal to limit n tends to infinity sigma r is equal to 1 to n square by, in the denominator, n square into 1 plus r by n whole square, and from n plus r take n common, n times 1 plus r by n. Now this is equal to limit n tends to infinity sigma r is equal to 1 to n, that n square is cancelled and 1 n will remain in the denominator, and that is 1 by n into 1 plus r by n whole square into 1 plus r by n. We recall this result from integral calculus, and this is the definite integral as the limit of the sum, and limit n tends to infinity of the sum, the infinite sum sigma limit of a sum. This is limit n tends to infinity of the sum sigma r is equal to 1 to n 1 by n f of r by n. Agreed. This is the limit of the sum is the definite integral, integral 0 to 1 f of x dx, and here is 1 by n is there, and f of r by n is 1 by 1 plus x square into 1 plus x. So this will be equal to integral 0 to 1 dx by 1 plus x square into 1 plus x. Now to integrate this one, we have to write it as the partial fractions, the sum of partial fractions. So I'll show you the partial fraction reduction here, and 1 by 1 plus x square into 1 plus x is written as ax plus b by 1 plus x square plus c by 1 plus x. And note down 1 plus x square is an irreducible polynomial, irreducible factor, because irreducible factor is a irreducible polynomial of degree 2. Therefore the numerator should be a polynomial of degree 1 less than the denominator. That is the a linear polynomial we have to write down, that is ax plus b. So that is the one, and take the LCM, you will get ax plus b into 1 plus x into c times 1 plus x square is equal to 1. Now put x is equal to x plus 1 is equal to 0, means x is equal to minus 1. Put x is equal to minus 1. The first term becomes 0 because of 1 plus x. And second, from the second term, for x is equal to minus 1, x square is 1 only. 1 plus 1, 2. 2c is 1, and that is c is equal to 1 by 2. Now equating the constant term on both sides. So the constant term is from this b into 1, b, and c into 1, c. B plus c, the constant term on the right hand side is 1. B plus c is equal to 1, and b is equal to 1 minus c. C is 1 by 2. 1 minus 1 by 2 is 1 by 2. Now equating the coefficient of x on both sides. 1 into ax, the a, b into x, bx, b. So a plus b is the coefficient of x from the first term, and there is no contribution from the second term, and on the right hand side there is no term containing x. Therefore a plus b is equal to 0. This will imply a is equal to minus b, and that will be minus 1 by 2. A is equal to minus 1 by 2. Now substituting back these values into the above one, then we get 1 by 1 plus x square into 1 plus x is equal to 1 by 2 into b. B is 1 by 2 plus ax minus 1 by 2. 1 by 2 is common, minus x into c is 1 by 1 plus x. So this is the partial fraction reduction we write down. So that is by partial fractions. Agreed. We continue in the next slide. So that's our limit intention for the big expression, that is equal to integral 0 to 1 by 2 into 1 minus x by 1 plus x square plus 1 by 1 plus x dx by partial fractions, which we have seen in the last slide. Now separate them. Then that will be 1 by 2 into integral 0 to 1 by 1 plus x square minus x by 1 plus x square plus 1 by 1 plus x square. Now if you integrate, this is dx by 1 plus x square integral 0 to 1, and that will be tan inverse x minus integral of this is multiply numerator and denominator by 2. Then you will get 1 by 2 into 2x by 1 plus x square, and integral of that will be 1 by 2 into logarithm of 1 plus x square to the base e, and this is log of 1 plus x to the base e. Thus we get tan inverse x 1 by 2 into tan inverse x minus 1 by 2 into ln of 1 plus x square plus ln of 1 plus x to be evaluated between the limits 0 to 1. For the upper limits, tan inverse x, tan inverse 1 is pi by 4, and minus 1 by 2 into ln of 1 plus 1 square, that is ln of 2. 1 by 2 into ln of 2 plus this is ln of 2. For the lower limit, tan inverse 0 is 0, and for minus 1 by 2 into ln of 1, that will be 0, plus ln of 1, that is 0. So the contribution is there only for the upper limit, and that will be equal to 1 by 2 into pi by 4 minus 1 by 2 into log 2 ln 2 plus ln 2. Now simplify, we'll get 1 by 2 into pi by 4 plus 1 by 2 into ln 2. Multiply, we'll get pi by 8 plus 1 by 4 ln 2. That's our answer. So the limit of n tends to infinity of that big expression is this answer. So let's look at our options. And our answer pi by 8 plus 1 by 4 ln 2 appears against option A. Therefore, our answer to this question is option A. That's our answer. That is the discussion of the solution of the problem on the definite integral as the limit of a sum. It is a routine example. Many a times such type of examples have come. And I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.